Dragons are amazing supernatural creatures that have captured our imaginations for centuries. Dragons such as Smaug from The Hobbit and those in the Game of Thrones and House of the Dragon have captivated audiences with their awe-inspiring flight and fearsome presence. But given the immense size of these creatures, can they exist as they show them in the movies? Can they fly and stay airborne given their massive size? We're going to examine this through the lens of science and physics to discover if these mythical creatures can actually fly. And before the end of this video, we'll have our answer and a solution that can make dragon flight possible as we see them fly in the movies. First, let's examine the problem of size and weight. For any creature to fly, it has to be able to generate enough lift to overcome its own weight. The relationship between weight and lift is well defined in biology and physics. As an animal's size increases, its weight grows cubically, while its wing area, which generates lift, grows only squared. This means that the larger the creature, the proportionately larger the wings would need to be in order to support flight. If dragons were the size shown in movies and on TV, their wings would need to be incredibly massive, spanning hundreds of feet. Even if such wings were physically possible, they would require an extraordinary amount of muscle power to flap, which brings us to the next issue: energy and muscle requirements. Flying is a very energy-intensive activity, and the muscles required to fly have to be strong enough to not only lift the creature into the air, but also sustain prolonged flight. Birds and bats have evolved incredibly efficient muscle structures that allow them to flap their wings and generate lift. However, even the largest known flying birds, such as the Andean condor, have a wingspan of around 10 feet and weigh no more than 33 pounds. Their muscle and bone structure are perfectly adapted for flight, yet they are still relatively lightweight. For a creature the size of a dragon, the muscle mass needed to lift such a weight would be astronomical. These dragons would require a heart that could supply massive amounts of oxygen to their muscles and lungs that could facilitate this exchange at an immeasurable high rate. Another good example is Quetzalcoatlus, the largest known flying reptile, which had a wingspan of up to 40 feet and weighed between 400 to 500 pounds. But they were relatively fragile, and their muscle efficiency was finely tuned for their size. Dragons, being much larger and heavier, would exceed the feasible mass to allow them to fly. Next, we have wing structure and lift. The wing structure of flying animals is critical for sustaining flight. Birds, bats, and insects have evolved lightweight yet strong skeletal structures combined with feathered or membranous wings that allow them to glide, flap, and maneuver in the air. These wings generate lift by creating a difference in air pressure between the upper and lower surfaces as they move through the air, a principle known as Bernoulli's principle. Dragons like Smaug have wings that are depicted as being large and leathery, similar to those of bats or pterosaurs. The problem becomes one of aerodynamics. While leathery wings can indeed support flight in smaller creatures, the surface area required to lift a dragon would be simply massive. Additionally, the wing bones themselves would have to be incredibly strong to support the weight, yet also light enough to allow for flight. The type of wing structure dragons such as Smaug and Drogon have could not provide the necessary lift for such a massive body. Moreover, if they had bones dense enough to support a creature of their size, it would only add to their weight, making flight even more impossible. Even if you launched Drogon off of a plane in the air at high speed, he would fall from the sky like a rock. His shoulders would snap if he tried to extend his wings, hitting the ground at terminal velocity. His rear legs alone are too heavy and have no aerodynamic features. Add his massive tail, and you have a creature that will plummet as fast as gravity can take it. And a dragon flying stationary in one place has an absolute zero chance of being possible. That brings us to the problem of metabolism and heat management. Flight demands an exceptionally high metabolic rate, as the muscles involved in flight require significant energy to operate. Birds and bats have high metabolisms that allow them to stay in the air for extended periods. To sustain this, they must constantly feed and fuel their body with a constant supply of energy. Dragons have multiple issues. Not only are they massive in size, but they are often depicted as fire-breathing creatures, which adds another layer of complexity. If dragons were able to breathe fire, their metabolism would have to support this ability in addition to flight, which would require even more energy. Endothermic creatures, those that generate heat internally, would struggle to fly and breathe fire simultaneously, as it would require an ungodly high-calorie diet. Furthermore, regulating body heat would be another major issue for dragons, particularly given their size and the amount of heat they would generate during flight. Without an efficient way to release heat, dragons would overheat and die. There is just no way around these basic physical laws. A full discussion of dragons would not be complete without mentioning evolutionary and anatomical constraints. In evolutionary biology, natural selection tends to favor adaptations that are efficient and practical for an organism's survival. Large, flight-capable creatures have existed in the form of pterosaurs, but even they were relatively light and fragile. The evolutionary path that would lead to a creature like a dragon is difficult to imagine. Animals that evolve to become larger typically lose the ability to fly, as seen in flightless birds like the ostrich and the emu. These animals have powerful legs for running, not wings for flying. A dragon's body, with its thick scales, massive wings, and fire-breathing capabilities, suggests that its evolutionary trajectory would prioritize strength and defense over the agility required for flight. Moreover, evolution tends to avoid creating animals that defy the laws of physics. Given the biological constraints of muscle strength, bone density, metabolism, and energy consumption, the chance is basically zero that any evolutionary path could lead to a flying dragon, as we see in fiction. The reality is that dragons the size of Smaug and Drogon could never come close to getting off the ground and achieving flight. The laws of physics, biology, and evolution impose limits on what creatures can achieve, which leads us to the only plausible reason dragons could exist and have a chance at flying like they do in the movies: magic. It's the only way it could happen. We hope you enjoyed our deep dive into dragons and invite you to join us in our next episode